And well, good morning, everyone. And my name is Yan, and I've been using AWS Web Services since about... OK, what's going on? And I've been using AWS for about 10 years now. And right now, I'm working for a company called Space 8 Games in London, where I make mobile games for a living. Some of our games has won industry awards, and we've also been voted one of the best places to work in the UK in 2017. And as of May this year, we've also partnered up with Supercell, who you may know as the creator for top grossing games such as Clash of Clans and Clash Royale. And what this partnership gives us is that strong financial stability that you need as a startup. And incidentally, it's also a lot more than I can say about my last startup, which was a social network called Yubbo, where we were trying to build something that's a mixture of Twitter, Instagram, and Facebook. And like most startups, unfortunately, we ran out of money and had to close down at the end of last year. But it was at Yubbo that I learned a lot about AWS Lambda and how to operate a serverless architecture in production. You see, when I joined Yubbo in April last year, I inherited a pretty standard monolithic backend system that's very simple on paper. But as you peel away the covers, you find all these hidden complexities and dependencies as well. And being a very early stage social network, we didn't have that many users, but we did have a few power users. So our traffic is often shaped by what those power users do on our platform. So one of our popular users would be running a social networking campaign on our platform, and all of a sudden we see a 50x, 100x spike in our traffic. So as a result of that, we run our EC2 cluster at a low utilization level, much lower than we'd like. And because scaling on EC2 is slow, we also have to scale up a lot earlier than we'd like as well. When you put the two things together, it means we are paying a lot of money for unused CPU cycles. At the time, deployment was also taking up to 30 minutes and required downtime, which in this day and age is clearly not good enough. And one of my favorite speakers, Dan North, once said that the lead time to someone saying thank you is the only reputational metric that we need. But to get that thank you, we have to first deliver some value to our users. And to do that, we have to ship our code. Until our software has been shipped, as far as our users are concerned, we haven't done anything at all. In order to build a better or good architecture, we have to first define what would the good architecture look like for us. So I sat down with the team, and we came up with a list of criteria that would define that goodness for us. We want deployments to be small, to be fast, no downtime. And we also don't want to get into a situation where we need to do lockstep deployment with the client applications. We also want features to be independently deployable and be loosely coupled through messages and events. And in terms of operations, I want to cut out all the fat we have in our AWS build and be much more efficient. And I want to spend less time babysitting our infrastructure. As far as I'm concerned, our architecture should work for us, not the other way around. And we also have lots of technical mess we have to address. And that's a very conscious choice of wording, because for something to be a technical debt, it has to be a conscious design decision for some trade-off with a plan to pay it back later on. And what I inherited was not that. And we didn't want to take 6 months out to address all these problems. We want to constantly be delivering value to our users. Whilst we do that, in fact, we want to do it faster than we've ever done. So all of this is pointing us towards a very different style of architecture. And if you fast forward a few months, we arrive at an architecture that is both event-driven and service-oriented, with Lambda being the centerpiece that glues everything together. At that point, we have over 170 Lambda functions running in production, and we were paying about 5% for Lambda, what we pay for EC2 for a comparable amount of compute. But perhaps more importantly, the sort of rate, or in terms of how we deliver things, how quickly we deliver things, has massively improved. Going from doing a production deployment once every 4 to 6 times a month, we were easily doing 100 deployments to production a month by October, with more or less the same size team as well. And for the moment, we decided that Lambda is a good fit for the direction that we're heading towards, to having that first Lambda function running in production. We had answered a bunch of questions around how are we going to do continuous delivery in this new world? What about testing? And how do we monitor things? And what about logging and alerting and so on? And as great as Lambda is, it's still just a tool. And as we change the tool that we build software with, often the practices and the patterns that has co-evolved with the previous tools, they have to change as well. But the principles, the fundamental principles that's behind those patterns and those practices, they still very much apply in this new world. Principles such as single responsibility, least privilege, loose coupling, high cohesion, and so on. And as the architecture expanded to have more and more functions, more and more services, many of them are interdependent, we had answered other questions around how do we do distributed tracing, and what about configuration management? How do we manage our configuration to keep them secure, but also in a way so that you can scale with our architecture as it becomes more complex? We're going to talk a lot more about those later on in the talk, but for now, I just want to talk about some of the things that we were able to deliver very quickly with Lambda. So when I joined the team, we had a search feature in the app already. At the time, it was just one big regex query against MongoDB, which, as you can imagine, wasn't going to perform particularly well. In fact, we were running into performance issues even with just 100,000 users, which in this day and age is nothing. And it was also very difficult for us to implement anything beyond rudimentary ranking on the results as well. So we went about building it from scratch by making sure first that our legacy system is publishing state changes to Kinesis as events so that we can hook up a Lambda function so that every time, say, a new user is created or user has updated their profile, we'll update a search index in Amazon Cloud Search, which is you can think of as hosted Solr. And then on the other side of the fence, we can create an API, a search API with API Gateway and Lambda, so that we can allow the client app to really easily search users by first name, last name, username, and so on. And as part of our migration process, without having to wait for the client to update to the latest API, we also proxy the legacy endpoint to hit the new API so that, again, we can deliver value improvements to our customers without having to wait for other teams to catch up. At the time, we didn't have an analytics pipeline, so we went about building it from scratch by having a Lambda function, again, consume events from Kinesis. And in this case, it would just live stream those events into Google BigQuery. So this piece of work took many iterations to improve along the way, but the first iteration went from the initial discussion to running in production in less than 2 days. And our BI guy, who's just joined us at that point, came to us afterwards and said, Jesus, guys, I can't believe you've done it already. Thanks so much. Nothing ever got done this fast as Skype, which is, well, no offense to anyone from Skype here, but it goes back to the point that we should optimize towards the lead time to someone being to say thank you for the good work that you have done. And as we got more comfortable working and operating Lambda in production, we started to tackle other more complex parts of our architecture. So in the app, we had a timeline feature similar to what you find in Twitter. Our implementation wasn't great, though. It was very complicated. It was hard to understand. And it was really bug-ridden. And in fact, there was a spec written for it, but the implementation didn't match the spec. QA team has no idea what it's supposed to do, and they gave up testing the whole thing. And by this point, the CTO that came in and sort of brought me in as well, he has fired everybody that was involved with the old server implementation. So we didn't have the previous team to sort of consult on what was it supposed to do. So we sat down with the product team instead of trying to reverse engineer what the previous system did. We worked out, okay, what do you guys actually want this feature to do? How is it actually supposed to work? And we built it from scratch, again, by consuming events from Kinesis and having Lambda functions that react to those events. For example, when you create a new post, we want to distribute it to all of your followers. So one of the Lambda functions will check your followers list and then group them into batches of, say, 100. And for each batch, send a message to SNS, which triggers another Lambda function that would then take that new post and add it to your followers' feed, which is stored as a sorted set in Redis. And the reason why it's proxying through SNS is so that we can leverage the retry mechanism you get with SNS and Lambda, and to avoid doing the expensive query for who are your followers. As you can imagine, some people may have tens of thousands of followers. Some may even get to have millions of followers. So that part of the operation can be really expensive. And when you retry, you're going to want to avoid doing those expensive queries against your system. Once we have the data where it should be, we also then create an API to allow you to fetch your feed. And as part of our sort of strategy for gracefully migrating to a new service, we also proxy the legacy endpoint so that the client team doesn't have to, we don't have to wait for the client team to update to the new API before we can, again, deliver value to our customers. Unlike most social networks, we had a recommendation feature. Unlike most other social networks, our implementation wasn't great. It was returning the first 30 users from the database by account creation time, which is great if you're an employee of Yabble, because you show up in this list all the time, but it's not so great for customers who is trying to find people that are relevant to them that they should follow. So I should implemented this feature again in the weekend, well, in the evening, by having a cron job, which is a CloudWatch schedule that runs every, I think, 1 or 3 hours, trigger Lambda function, because we have all the state changes in the system in BigQuery already, and BigQuery is well optimized for doing those ad hoc queries and respond very quickly. So we can find out who are the current trending people on the platform based on how many new followers he's had, how many people like his post, retweet his post, and so on. And now save it in a DynamoDB table, so I can put an API in front of that, so that you can find out who the current trending people are in the platform via API call. And whenever your state change, so whenever your relationship changes, where you follow someone, unfollow someone, those events are then processed by Lambda and used to update a social graph that is stored in the GrapheneDB, which is a hosted version of Neo4j, so that I can put an API in front of that so that you can quickly get suggestions based on your social graph. So, for example, give me the people that I should follow based on my second or third degree connections. So those are people that are followed by the people you follow, or people that follow the people that follow you, and so on. Again, without having to wait for the client team to catch up, we can proxy the legacy endpoint to then hit these two new APIs, combine them together. So in the evening, instead of returning first 30 people from a database, I can return people that you may be interested in following because they are currently trending on our platform, or because they're connected to you by second or third degree. So that's just some of the work that we're able to achieve with Amazon Lambda very, very quickly. But for the rest of the talk, I want to focus on the operational aspects, things you need to consider before you go into production. And I guess the number one thing I would say is that you should choose a deployment framework and stick with it. Don't try to invent your own. It's just not worth the effort. That's the kind of heavy lifting that we want to move away with Lambda. And the framework that we chose is called Serverless. And the reason we chose it over other frameworks is because, well, A, it's got a commercial company behind it. They're well-funded, and there are full-time people working on a framework, so you can expect regular updates and bug fix and so on. And even back then, they had a lot of community support. In fact, since we adopted it, they went through a major version update and fixed a lot of problems with the initial implementation. So they've had that chance to learn from their mistakes and improve upon it. And since then, Amazon has announced their own framework as well, SAM, or Serverless Application Model. And then there's Apex, there's UP, there's Cloudia, Zappa, Sparta, and then there's a new one pretty much every single week. I think the important thing here is that try a few of them, pick one that works best for you and your team, and just stick with it. What you want to do here is to optimize for knowledge sharing within the team and try to minimize the amount of friction you have when people move between projects. As you move between projects, as we often do in my team, you want to make sure that people don't have to spend effort and time to learn how to deploy this new system they're working on. It should all just be the same from one project to another. They should spend their effort and energy on learning about a new code base and a new problem domain. In terms of testing, once you start writing a function, you're going to want to test them. And this is the best book I've read on the testing in general. Growing Object-Oriented Software, Guided by Tests by Ness Price and Steve Freeman. And it talks about the 3 levels of testing, from having unit tests that test your code at the sort of object and module level. And you can still do that with Lambda. Ultimately, it's still just code. So if you've got some business logic encapsulated in a module, just write tests against that module. And then you've got integration tests that test your code against things that you can't change. And since Lambda ultimately is just a function that Amazon is calling for on your behalf when some event happens, you can still just invoke your function by calling it with a stub, the event, and the context. The important thing to remember about this integration test is that the purpose of it is to test your code against things you can't change, so the ecosystem. So when you run this test, you should wire your function to hit the real downstream system rather than mocks and stubs. And we'll talk more about that later on. And then you've got acceptance test where your code has to be deployed. Now you're verifying that the whole system works end to end. And as you go up and down this triangle, unit tests give you the best feedback loop, the fastest feedback loop, but the acceptance test is going to give you the most confidence that what you have actually done actually works according to your use cases. And one of the things I learned from this book, and I will quote, this is quite long, that we find that tests that mock external libraries often need to be complex to get the code into the right state for the functionality we need to exercise. The mess in this test is telling us that the design is not right, but instead of fixing the problem by improving the code, we have to carry the extra complexity in both the code and the test. And the second risk is that we have to make sure the behavior we stub or mock actually matches what the external library will do. And even if we get it right once, we have to make sure that the tests remain valid as we upgrade the libraries. And I think the same principles apply in this increasingly service-oriented world that we live in, or serviceful world that we live in, as many people call it nowadays. That there's all these services that you're consuming, you don't control them, and you shouldn't try to waste effort on mocking and try to make sure that your mock matches what they're actually going to do. And I think when it comes to testing a serverless application, this is even more so the case. Because when you're writing your test, focusing on what's inside your Lambda function and stubbing out all of your external dependencies, you're missing out a lot of things that is likely to go wrong once it's been deployed, because Lambda functions has got a lot of configurations. And typical things I stumble on is I make a change, now I start using a new table, and my IAM policy is not updated accordingly. So the first time I deploy it, maybe I run my test with mocks, and it all runs fine. The moment I deploy and try it out, it says, nope, your function cannot talk to this DynamoDB table. And a lot of the resource creations can also be automated, and I consider that to be part of my software that need to be tested as well. So if I'm depending on new table for this new feature, it needs to be created in some automatic way without having someone to remember to go and create it in production and so on. And all of those things need to be included in your test to make sure that it's working. And with Lambda, you have the unit that you need to consider, the sort of boundary where the configurations and everything is increased so exponentially compared to services that are essentially a bunch of different features that's deployed in one unit. With Lambda functions, these are all tiny, tiny units that each one of them you need to make sure is working correctly once it's been deployed. And one of my observations is that most Lambda functions themselves are actually really simple and often just have single purpose. And the risk of you delivering something that's broken has largely shifted to the configuration of those functions, as well as how your functions interact with other services. And since the whole purpose of us writing tests, since the whole purpose of us writing any code at all is so that we can deliver working software at the end of the tunnel, that's the goal we should optimize towards. And since more and more things that can fail are now outside of our code, and I think acceptance tests, end-to-end testing, has now become increasingly important in the world of Lambda. Even if we have to sacrifice some of the feedback loop that we enjoy as developers, I think it's worth the while. There's a whole lot of new tools that's come up into the ecosystem now that allows you to test your functions locally, and I think they're great. You should definitely use them, but you should use them to complement the existing end-to-end automated tests rather than to replace them. And the good news is that most of these services you're going to be using, they're quite easy to set up and to test with anyway. And on end-to-end, on acceptance testing, Ned and Steve also have this to say, that wherever possible, an acceptance test should exercise the system end-to-end without calling into its internal code. And the end-to-end test interacts with the system only from the outside through its interface. So if you go back to the search API we implemented earlier, to test this, we will create the test conditions by talking to the legacy system through its HTTP interface. And then we will observe that after all the background processes happen within a reasonable amount of time, the new user that has just been registered on the system can be searched via first name, last name, and username, and so on. Another thing we notice is that for when we have this kind of setup where the integration test is invoking the function code locally, but talking to the real downstream system to test your integration points down there. And once you've deployed your code and you're running end-to-end tests, you're interacting with the same bit of code, but through API gateway and other event sources that Amazon has. So the only thing that differs between these two types of tests is how your Lambda functions code executes. So you can actually make it easier for yourself by writing your test cases in a way that's reusable. So when we define our when steps for some fictional endpoint, we can actually have a toggle inside it so that based on some environment variable, you either invoke the function with a stubbed context, an event, or you'll be calling the HTTP endpoint directly. Put together a small demo for you to look at as well on GitHub. The slides will be shared afterwards, so you can go check it out. And then with continuous delivery and setting up pipelines for that, I think there's a temptation when you're starting a new project to leave it towards the end of the project. But since it's a mechanism to save you effort and also save you from human error, I think it's a strong argument for you to put that up very early. And one of the reasons why this is often done late in the cycle is because there's a lot of work involved. This kind of thing is not easy to set up. But I think that changes with Lambda as well. On testing things end-to-end, Steve Knapp also says that we prefer to have the end-to-end test exercise both the system and the process by which it is built and deployed. This sounds like a lot of effort, it is, but it has to be done repeatedly anyway in the software's lifetime. And this goes back to the earlier point I mentioned about the creation of your DynamoDB tables and so on. Those resources should be contained as part of the things that your software is deployed with. And that's easy to do nowadays with a serverless framework and a whole bunch of other automation things you can do with Lambda. And one of the things that really annoys me when it comes to setting up a continuous delivery pipeline is having all these custom steps that exist only as a custom script on the Jenkins and nowhere else. So that is obviously a formula for a recipe for disaster. Someone's going to change it, break it. You have no idea who did it, when, and more importantly, what was there before, so you can quickly roll back and fix it. So as a rule, in every single one of our projects, and we have many of them, we will have a very simple build script that just builds on top of what the serverless framework and NPM gives you already. And being a terrible bash script writer, everything is very simple. All I'm doing here is giving you a very lightweight DSL so that we can say build script deploy, and it's going to do the npm install. And one of the things we do is, as well is to install the serverless framework as a local dev dependency for that particular project so that you mitigate problems around version compatibility. So if someone's installed a new version of serverless framework, goes to a project with older incompatible version, they want me to deploy your code. You don't want that, so instead you essentially log your project to the version of serverless framework that it was created with by doing this, so that in our build script, when you deploy, you use the local version of a serverless framework and deploy to multiple stages and environments and so on. And we also use it to trigger unit tests if there's any, integration tests, do the deployment. Then once everything is deployed, we also run the acceptance test end-to-end as well, all using NPM scripts. It's all very simple and easy, and because it's a script, you can run it locally the same way that you do on a Jenkins box. In terms of continuous delivery versus deployment, we were doing continuous delivery where to production is the manual step, someone pressing a button on Jenkins. We don't do deployment on Friday because we also have Friday Jenkins in the evening. So in this setup, where every time you push your code into master, we are doing Git flow as well. So before it hits master, there's a code review process that happens where we require at least half the team to sort of agree on what you've done. But even before you start writing code, we have a convention to have a PR just for, if it's a big enough feature change, to discuss your approach, what you're trying to do, so that you don't get to the point where someone at the end of your couple of days of work, a week's work, say, oh, you shouldn't have done that. You could have done this instead. So we try to move that discussion early on, try to agree on at least the high-level design for what you want to do, then go ahead, implement it with a small two-man team, and then have a code review process that involves the bigger team in scope. Once it's been pushed, you run unit tests, integration tests, deploy, acceptance tests, and when that passes, you move on to the next environment, and the next environment, and right before production, when there may be some discussion with the product team in terms of when those deployments should happen, but for most of our services and most of the things that we change, we make sure that it's backward compatible and we can proxy the legacy endpoint so that, again, deliver value earlier. So most of the deployment to production is actually just someone doing a sanity check. Yep, we should do this. And for logging, whenever you write to standard out from a Lambda function, Lambda service captures that and sends it to CloudWatch logs for you asynchronously without adding latency to your function invocation, which is important. And you also get some additional information around timestamp and so on. And you can find all of your logs organized in the CloudWatch logs by function, which is all well and good. But the problem with CloudWatch logs is that it doesn't make your logs easy to search. And it becomes a much bigger problem as you have more and more functions to your architecture. And this is a common problem people will run into in the microservice as well. So the consensus there is to have a centralized log aggregation service where logs can be easily searched. And the popular choice there is the Elk stack. And when you have logs for a Lambda function, you can actually go to the CloudWatch logs console to have them stream directly to the Amazon's hosted Elasticsearch service, or you can have it, say, stream to a Lambda function. In that case, your Lambda function can then send those logs to your maybe self-hosted Outstack or some other Splunk or other service provider they use. Another thing to keep in mind is that every time you create a new function, you also create a new log group, and you don't want to have a manual process for someone to then go and click the button to stream that new log group to your log shipping function. And what you can do is enable CloudTrail so that you can then create an event pattern in the CloudWatch that whenever the create log group API call is called, it calls another function. What it's doing is subscribe that new log group to your log shipping function. Another thing to remember is that when the Amazon creates a log group for you, it sets the retention to never expire, which obviously has got a long-term cost implication. So what you could do is do the same thing we did earlier, CloudTrail, create log group event, Lambda function to automatically set the retention policy to, 30 days or something. I actually created some code demos that you can use if you go to the link on this slide here. And it's all well and good having all of your logs in one place and easily search, but often a feature only works when many different functions are working in perfect synchrony. And even if one part of the process breaks, you may end up with a case someone coming to you and say, hey, I created a post, but my wife didn't get it. What's up with that? And trying to debug this kind of problem is kind of hard because you have so many different functions you need to look at. Problem can happen in any one of them. And in production, logs are just everywhere. It's hard to correlate them. So that's where correlation IDs comes in. And since your correlation IDs since the processing of the data is flowing through APIs, SNS messages, Kinesis events, and so on, it means that your correlation IDs also have to flow through all of those sources. And the way we approached this was to create our wrapper libraries for Kinesis and SNS and HTTP so that we can easily capture. Oh, right. So for individual functions, we also got a wrapper function to allow you to create a new handler for, say, API gateway. And part of that, it encapsulates the common things that we do, including getting the correlation IDs from HTTP headers, so that in the log modules and the other sort of custom client libraries, you would then know to fetch them and send them out to the next event source. Again, there's a code demo that you can follow if you go to the link here. Another thing that's involved with distributed tracing is diagnosing performance problems in your system, and that's where that's why Amazon announced the X-ray at the last re:Invent, where with X-ray you can see what happens inside your function. It requires some custom code for you to write to publish those individual steps. But once you have that, you can use X-ray to see the trace of your function, what happens. And you can also use that data to create a service map so that you can have a high-level view of what your function is using and how much execution time you spend doing each of those things. The problem with API gateway, well, with X-Ray right now, this is the biggest one for me, is that it doesn't support API gateway. So when your function calls another function via API gateway endpoint, it loses the fact that, the execution span across this API call. So you don't see what happens inside the second function. You only see how long the HTTP call itself takes, which makes it a lot less useful, especially when you have a microservice architecture where services often call other services to fetch information. There's a few other problems I ran into when I started using X-Ray. Again, you can read more about them here. I've been doing a lot of writing on Lambda. So moving on. One of the things we tend to do with EC2 services is to install monitoring agents, but now that we don't have access to the host, we can't do that anymore. So we are very much relying on what the metrics we get from CloudWatch. There's a couple of other providers that announced support for Lambda, but most of them are just using the same metric that they get from CloudWatch, but give you a better looking dashboard. The IOPipe guys do something slightly different. With their offering, they give you a library that you can use to, again, like what we do for ourselves, create a wrapper for your function code so that they can intercept your invocations and then send metrics to their backend system, and they can include additional information around memory usage and CPU usage and so on. The problem and why I don't use IOPipe or similar services is that it adds that communication to IOPipe has happened within my function invocation. And API gateway doesn't respond to my customer until my whole invocation is finished, which means when someone pressing a button expecting something to happen, they have to wait that 30 millisecond or 50 millisecond longer and on every single HTTP call. And this is the same if you send custom metrics to CloudWatch yourself as well. In fact, as a technology, we just lose the ability to do background processing outside of the critical path where the customer is waiting for a response. So typical things that we like to do before, sending logs and metrics in the background so that we respond to the HTTP request first, and then we do all this background processing. That's all gone. Everything has to be done during the function's invocation. But there's several ways to mitigate this additional latency. And the best one I found is how Datadog supports custom metrics. Essentially, it's using the fact that you still get background processing with the things the platform does for you, including taking logs from standard out to CloudWatch logs. So if you write your metrics as specially formatted log messages, then you can actually process it in your Lambda function. Instead of sending them as logs, you send them to CloudWatch. This is not the right approach for everything, because that means to see your metrics, there's now a bigger latency, there's a bigger delay. So what I would say is that where you are building an API, where latency is sensitive, then you should consider this approach to do metrics tracking asynchronously. But for background processing, where you're less worried about that extra 30 milliseconds, then just send those metrics in your function invocation. Again, don't have to do it yourself. I've got some code demos that you can follow along. And once you've got all your metrics, set up dashboards, alarms, and track custom metrics for application-level metrics, for example. And one thing to consider is that CloudWatch is it's a pretty good service. It's fairly cheap, and sometimes it's the only way to get metrics out of Amazon services like Kinesis and DynamDB and so on. But it doesn't have the best UI. It doesn't have some of the more advanced features like anomaly detection you find in Stackdriver and the Wavefront. But the biggest problem I have with CloudWatch is that it's got a tendency to go down at the same time as the services that it monitors. So this happened to me a few times where, okay, Amazon's having a hiccup. My service is being interrupted. I don't know how badly because I also don't have my metrics. And I often don't know when things come back to life. So it's not a great place to be. So if you want to, so I'm constantly on the fence, going back and forth between should I use CloudWatch as my primary monitoring system or should I not? Yeah, I'm not decided for now. I'm just sticking with CloudWatch for the time being. Okay, we've slightly run out of time. So configuration management. The sort of golden standard is to make sure that your approach allows you to easily and quickly propagate any config changes. Nowadays, when you create a Lambda function, you can specify, the UI has changed, by the way. You can specify the environment variables, and you can even have KMS encrypt them for you. And this is the approach that we started off with. But what we found is that there's another problem with it. For starters, it doesn't make it easy for you to share configurations across multiple functions. And it also makes it hard for you to implement fine-grained control to those sensitive data like API keys and so on, because environment variables are baked in at the deployment time. It means that in order to deploy a Lambda function with access to sensitive data, me, the deployer, needs to have access to those sensitive data as well, which means I will need to be able to, say, decrypt production API keys and so on. And often in a bigger team, for startups, it probably doesn't matter. Everyone's got access to everything. But for a bigger team, maybe even for those working in the regulated environment, you need to have that separation that the people can deploy their code, great, and you want that. But you don't, at the same time, you don't want everyone to have access to those sensitive data. So the approach we went with was having a centralized config service. Looked at console, looked at XCD. Didn't really fancy either of them because, again, I go back to having to manage and pay for each two services, having to have multiple instances so that I get high availability. And there's also a learning curve with both, including how to manage and configure the service and how to use it and how the command line tools and so on. So we went with just having a home-baked config service. And since then, Amazon announced the SSM parameter store is the last reinvent. So nowadays, you should just use that. As I mentioned, if you've got sensitive data like API keys, credentials, and so on, those should be encrypted at rest and in flight, and you should have role-based access. And fortunately, SSM parameter store gives you both. So in this case, maybe you have someone like a system admin that's got access to those production information, sets them up in parameter store. They are encrypted with role-based access. Then when your function is deployed, as a deployer, I don't need to have access to the secrets themselves. I just need to be able to give my function the permissions to access them. And so my function runs up, gets them from SSM parameter store at runtime, decrypts them, and keeps them in memory. So the only time those secrets are in plain text is when it exists in the memory of my Lambda functions runtime, as well as in the heads of my system admin. And also, you want to invest time into writing a robust client library that supports caching and so on, and also have the ability to. So you cache them, fetch and cache them at the cold start, and then you want to be able to invalidate the cache the configs at some interval. Or if you're using it for, say, service discovery purpose, then you can use, for example, OK, at the start, cold start, I find out that the user API is at this URL. I keep making a call to that URL until such a point that I'm getting 404. So maybe there's a signal that URL has changed. So OK, at that point, fetch a new configuration value. Again, all of that is available as a blog post. And since we are out of time, I'm just going to skip the last section. And just thank you for your time. So most of that have written in more detail as a blog post, so you can follow the link and read all about it yourself as well. Unfortunately, we don't have time for Q&A, but if you find me in the hall, just come and grab me anytime you want. Again, thank you. All right.